Good day, class. Ang unang topic natin for our midterm is rectifier circuits. Okay, sa topic na ito, matututunan natin how to calculate and determine the waveform of different rectifier circuits. And we will also recognize half wave and full wave rectifiers and explains the operation of these rectifier circuits. But before we start, punta muna tayo sa pinakamahalagang component o part ng rectifier, which are transformers. Transformers transforms electrical energy from one circuit to another circuit at the same frequency. So, ang trabaho lang ni transformer is to increase or decrease the AC voltage. And transformer are electrical devices consisting of two or more coils of wire used to transfer electrical energy by means of a changing magnetic field. Kung mapapansin nyo sa pictures na ito, meron tayong AC supply. Pwede niya yang i-increase, palakihin yung supply. Pwede niya rin yan paliitin. Depende doon sa number of coil na nasa transformer. Dito sa secondary at sa primary coil, pwede natin yang i-increase depende sa number of inputs or outputs na ilalagay mo. So, kung nakakita na kayo ng transformer, ganito ang kanyang itsura. Yan. Ano ba yung construction ng isang transformer? Meron siyang primary coil, meron siyang secondary coil. At ganito ang symbol ng isang transformer. VP o yung makikita natin dito, ang tawag dyan ay primary voltage. At ito namang VS, ang tawag dito ay secondary voltage. At ito namang NP, ang tawag dito ay number of primary windings or primary coil. And yung NS is number of secondary windings. At ito namang symbol na ito, flux. Ang tawag dyan ay flux linkages. The greater number of turns, the higher the voltage. Kung mas marami yung number of coils dito, ibig sabihin, mas mataas yung voltage dito. The same with, kung mas marami yung number of coil dito, ibig sabihin, mas mataas ang voltage dito. There are two types of transformer. The step-up transformer, ang ibig sabihin lang nun, mas mataas si secondary kaysa kay primary coil. Kaya siya tinawag ni step up. For example, nag-supply ako dito ng 5 volts. Ibig sabihin, ang ma-receive ko ditong secondary voltage is above 5 volts. Step down transformer naman, si primary voltage is greater than kay secondary voltage. Ibig sabihin, mas mataas si primary and i-step down niya yung voltage dito sa secondary voltage ng transformer. Okay. Ano ba yung equation ng transformer? Simple lang. Okay. Primary voltage over secondary voltage is equal to, kung current yung kukunin natin, nasa ibabaw yung secondary current over primary current is equal to primary windings o number of primary coil over number of secondary coil. Okay, let us try to solve some sample transformer circuit problem. Sabi dito, a transformer has 500 turns of the primary winding and 10 turns of the secondary winding. The question is, determine the secondary voltage if the secondary circuit is open and primary voltage is 120 volts. So, ibig sabihin lang nun, secondary circuit is open, magkoconnect tayo dito ng voltmeter, wala ditong load. Ibig sabihin, kung ano yung makukuha nating secondary voltage dito, yun na yung magiging secondary voltage natin. The formula, again, meron tayong primary windings, meron tayong number of secondary windings, at meron tayong primary voltage of 120 volts. So, ang formula natin is primary windings over secondary windings is equal to primary voltage over secondary voltage. So, 500 over 10 is equal to 120 volts over our secondary voltage. At kapag yan, i-compute natin, makukuha nating secondary voltage is equal to 2.4 volts. Kung mapapansin natin, ano nangyari sa ating voltage from 120 volts naging 2.4 volts. Bakit? Kasi mas mataas si primary windings kaysa kay secondary windings. Ibig sabihin, yun ay step down transformer. Sa second problem natin, sa B, determine the current in the primary and secondary winding given that the secondary winding is connected to a resistance load 15 ohms. So, meron na tayong load resistor na 15 ohms. So, using Ohm's law, makukompute natin yung secondary current. Secondary current is equal to secondary voltage over secondary resistor. Ano ba yung secondary voltage na na-compute natin? 2.4 volts over 15 ohms. Kaya makukuha natin na current dito sa secondary is equal to 0.16 ampere. Assuming, lagi naman natin ina-assume na ang transformer natin ay lossless. In this case, electric power on the coils, it applies. So, ang power natin ng primary voltage ay equal lang sa power natin sa secondary part ng transformer. So, ang formula ng power, primary power is equal to primary voltage times primary current. And secondary power is equal to secondary voltage times secondary current. So, ulit, assuming na ideal yung transformer natin or lossless transformer. So, ang power natin ng both part, primary and secondary, ay equal. Itatranspose natin yung both formula sa ating lossless transformer equation. So, ganito na yung mangyayari. Primary voltage times primary current is equal to secondary voltage times secondary current. And, palitan natin tong secondary current natin using our formula na ginamit natin kanina on solving our current. Ito yon. Secondary voltage over load resistor. So, ganito na yung magiging formula niya kapag in-arrange natin for us to compute yung primary current. Meron tayong secondary voltage given na na-compute natin, 2.4 volts. And meron tayong load resistor na 15 ohms. At meron tayong primary voltage na 120 volts. So, pwede na natin i-compute yung primary current. Primary current is equal to 2.4 times 2.4 over load resistor na 15 over 120. Makukuha nating primary current is equal to 3.2 milliampere. Next, a transformer is made to convert 20 volts AC to a higher voltage. The current in the primary side was found to be 6 ampere and on the secondary side is 2 ampere. So, itong formula to ay ginagamit natin kapag wala tayong load resistor. I-compute lang talaga natin yung doon sa may winding na current. Ang tanong, calculate the secondary voltage as well as the secondary number of coils if there are 50 primary coils. Okay, yung formula natin na secondary current over primary current is equal to primary voltage over secondary voltage. Given yung ating current, 2 ampere over 6 ampere is equal to 20 volts over our secondary voltage. So, kapag kinompute natin, makukuha nating secondary voltage is equal to 60 volts. The next question here is calculate the power both sides. Ay, meron pa pala tayo dito na kailangan i-compute. As well as the secondary number of coils if there are 50 primary coils. Kung meron daw tayong 50 primary coils, ano daw yung secondary number of coils? Meron tayong primary voltage na 20 volts. At meron tayong secondary voltage na na-compute natin na 60 volts. So, makukuha nating secondary number of coil is equal to 120 50. Ang tanong, is the transformer step down or step up? Using the number of coils ng primary is equal to 50 at yung secondary coil natin is equal to 150. So, yung primary is less than the secondary. Therefore, transformer is a step-up transformer. Next, calculate the power on both sides. So, assuming ulit na ideal transformer o lossless transformer. So, ang formula, primary voltage times primary current is equal to secondary voltage times secondary current. So, yung primary voltage natin is 20 volts times yung current na 6 ampere is equal to 60 volts times yung current natin na 2 ampere. So, yung power natin both side is equal to 120 watts. Another kind of transformer, yung kanina, simple na transformer, step up o step down transformer. Ngayon, center tap transformer naman yung gagawin natin. Ang center tap transformer, it is designed to provide two separate secondary voltages at voltage at point A and voltage at point B with a common connection. It is a type of transformer configurations produces a two-phase kasi meron tayong isang phase dito na produce natin ay dalawang phase. Opposite sila. Kung ito ay positive yung start, dito negative half cycle siya nag-i-start. Secondary voltage are the same. So pare sila ng value and proportional to the supply voltage. Therefore, power in each winding is the same. So, yung power natin in each winding are the same. Voltage produces across each secondary winding is determined by the turns ratio as shown in the figure. Yan. Mamaya i-discuss natin yan. The tapping point is in the center, exact center of the secondary winding, providing a common connection for two equal. So, two equal voltages yung makakompute natin but opposite secondary voltages. So, equal to pero opposite. Kapag ito ay positive, ito ay negative. Kapag ito naman ay negative, ito ay positive. So, nag-alternate sila ng voltages. Again, remind ko lang sa center tap transformer. For example, meron tayo ditong 1:1 ratio. Ibig sabihin, parehas lang siya. Kapag nag-supply ako dito ng 5 volts, ang mariread ko dito ay 5 volts. Kasi 1:1 ratio. Pero, ang kinaibahan ni center tap, i-divide niya kung ano man yung marireceive na secondary voltage, i-divide niya sa 2, kakalahatiin niya. At yung kalahati, mapupunta sa isang winding, at yung isa naman, mapupunta sa kabilang winding. For example, again, yung ratio natin is 1:1. Meron tayong 10 volts. Ibig sabihin, meron tayong 5 volts dito, at meron din tayong 5 volts sa kabilang windings. Okay. Next, punta tayo sa sample problem ng center tap transformer. A center tap transformer with the ratio 10:4 has a primary voltage source of 100 volts. The question is determine the secondary voltage at point A and point B of the transformer. Center tap secondary voltage is always equal and opposite in polarity. Yan. Kanina, diniscuss ko yan. Equal dapat yung makakompute natin, pero opposite ang kanilang polarity. Secondary ratio must be divided into 2. Kaya yung 10:4 natin, yung secondary ratio na 4, ay dinivide natin sa kalahati. So, 10/2 is equal to 100 over our secondary voltage. So, secondary voltage na makakompute natin dito is 20 volts. So, may 20 volts tayo sa isa at may 20 volts din tayo sa kabila. Pero anong pinagkaiba? Again, opposite in polarity. So, meron tayong 20 volts doon sa point A, meron tayong negative 20 volts sa point B. Series center tap voltage is the sum of the secondary voltage at point A and point B. Balik tayo dito. Tanong dito, determine the secondary voltage if point A and point B connected in series. Kung tatanggalin ko to, itong nasa center, at i-connect ko to sa series, it will act like a simple transformer na diniscuss ko kanina sa itaas. Yan. So, dahil dyan, kung siya ay mag-a-act na simple transformer, hindi madi-divide sa 2 yung ating ratio. So, pwede na nating pag-add-in yung voltage natin sa point A at point B. Ang mako-compute nating secondary voltage is 40 volts. Kasi naka-series na siya. So, mag-a-add yung voltage across point A and across point B. This one naman is different. Ang configurable tap transformer. Ibig sabihin, hindi na siya sa center nag-tap. Meron tayong ratio na 2 sa isang winding sa secondary at meron tayong ratio na 3 sa pangalawang winding sa secondary. So, sagutan natin ito. At a configurable tap transformer with ratio 10:2:3 has a primary voltage source of 150 volts. Question is, determine the secondary voltage at point A and point B of the transformer. Punta muna tayo sa point A. 10 volts over 2 is equal to 150 volts over our point A. Okay. So, pag kinumpute natin yan, 10:2, ito yan, 150 volts yung ating primary voltage. Ang makakompute natin na voltage at point A is equal to 30 volts. Habang sa kabila naman, 10 over 3 is equal to 150 volts over voltage at point B is equal to 45 volts. Bakit ginawa ka itong positive? Pwedeng ang sagot nyo dito ay negative, pwede rin positive kasi alternating circuit naman siya. The same here, pwede rin ang sagot nyo dito ay positive or negative dahil alternating circuit naman siya. Okay. Next, problem at 2B. Determine the secondary voltage if point A and point B connected in series. Again, tatanggalin natin yung gitna, i-connect natin sa series, pag-a-addin lang natin yung voltage at point A and voltage at point B. So, ang secondary voltage natin is 30 volts plus 45 volts is equal to 75 volts. So, yan yung topic natin about transformer. Yung next video ko, I will discuss about rectifier naman. Okay. So, aralin nyo to and wait nyo lang yung next video ko.